So now what I want to do is turn our attention to sort of characterizing the ecosystems around us. And for that, we need to have a solid understanding of vegetation classification. So what I mean by vegetation classification is when we look at the natural arrangement of ecosystems here in the Mid-South, I want you guys to come away with a solid understanding by the end of this class. You know, what are the various forest types? What are the various types of grasslands? And where might you find certain kinds of wetland communities? So to really have to have a firm foundation in community classification or vegetation classification. And then we're going to weave into this story a lot of sort of secondary stories and ecological lessons and those kind of things. So quickly, just some key points. Number one, communities process. The way ecosystems and communities are formed is a population process. That means that communities they don't migrate as a community. You know, when we talked about, for example, glaciers advancing south and covering up part of the continent, and we talked about how different types of ecosystems sort of shift, right? Like tundra is shifting south ahead of the glacial front. But it's not really the ecosystem as like an organism. The ecosystem is not what is making a conscientious decision to move. The movement of that ecosystem is the response of individual populations of individual species. I'm sure that's pretty understood by most of you. But it's the collective response of individual species that are moving together, and some of them don't move. Some of them are stuck where they are, and so they may become extinct. Others may be more successful at migrating, and therefore they move. And so when you have a collection of species, let's say those that inhabit tundra conditions, and they begin individually moving in response to some type of environmental stimulus like colder climate or less rainfall, then they're probably going to respond similarly and move in similar patterns, so that it might appear that the whole ecosystem is changing as one, but really it is a population-driven process. This kind of runs counter to what was thought many decades ago, when ecosystems were thought to be sort of like a superorganism. They were thought to sort of move as one unit. That's really not the case. And secondly, communities are sections of continuous gradients. That means they just sort of bleed into one another very gradually. There's all these gradations in between. So a forest type might grade into a woodland type, and a woodland might grade into a savanna, and a savanna might grade into a prairie. And then these are connected where they kind of come together by what we call ecotones. These are the types of the boundaries between community types, or the zones of intergradation between two different community types. Now, communities do show some directionality and predictability. I'll try to illustrate that as we go through the lecture. That's a little bit harder one to sort of define right here. Communities are strongly influenced by historical effects. Part of the reason why I spent the last 3.5 lectures going through American history is so that you'll have a stronger underpinning and a foundation for what kinds of history is relevant to this region. But what we mean here especially is things like fire and disturbance events such as tornadoes or hurricanes or windstorms. You could have hailstorms. These are all types of historical effects. And communities are strongly influenced by whatever processes have kind of come through and affected them. Number 5 is a really critical one. We're going to hammer on this a little bit. Communities do not develop to a stable climax. I'll come back and we'll talk about this on a couple of the later slides. Communities are dynamic, which means they're always changing, and they are influenced by disturbance, like fire or wind or big animals, those kind of things. Let's go back and address this point number 5, which communities do not develop to a stable climax. A really foundational ecologist by the name of E. Lucy Braun, who lived from 1889 to 1971, was really one of the big proponents of what's called climax communities. Braun basically theorized that a given region has a climax type, a climax vegetation type, and that under certain climatic scenarios and certain types of environmental parameters, that a given region will develop into a climax vegetation type. So for example, here in Middle Tennessee, where we have enough rainfall, we have a temperate climate, we have 55 inches of rain per year. She theorized that everything would eventually progress to what's called a mesophytic forest, which is eventually, more or less, that's just another way of saying a moist type of forest. That is the climax vegetation type here in Central Tennessee. If we just simply left nature to itself, she said, Middle Tennessee will develop into a mesophytic forest. But yet, when the first settlers got here, they didn't document mesophytic forest in many regions. They documented prairies or savannas or meadows or swamps. And so it sort of begs the question, well, is that true? Do climax communities really develop? Later researchers throughout the later 20th century have sort of devalued this idea of climax communities. And part of the rationale is that we have things like fire, and we had megafauna, and we had people. And so generally the consensus is that communities don't really have the ability over a long period of time to ever achieve some type of stable condition, that they're always changing in response to climate change or other kinds of environmental change or some type of factor, that very rarely do they stabilize. But Braun has left a lasting legacy. This idea of climax communities was the prevailing thought whenever I was in school in the 1990s and early 2000s. And many people today still hang on to this notion of climax communities. Now, another thing that Braun gave us is this overreaching concept of the importance of forests to Eastern North America. And she published a book in 1950 called Deciduous Forests of Eastern North America. And one of the quotes very early in the book reads as follows: when the first settlers colonized the Atlantic seaboard, and later when hardy pioneers pushed westward over the mountains, they found an endless expanse of forest broken only by swamps and bogs, by cliffs and river bluffs too steep for forest, by windfalls, that's basically areas where tornadoes have blown down the forest, and by burns, by small grassy openings. The forest was a hindrance to travel, a hazard because of lurking Indians, unfriendly to the invading white man, and an obstacle to homesteading. So basically, it was an obstacle to anybody that was trying to put up a cabin or a town or a village. And as land must be cleared for home and produce. I want you guys to think about this paragraph for a bit. And I would love to just hear from several of you what your thoughts are about it in light of the 3 lectures that we've had on American history. I know some of you haven't watched the last 2 videos. That's okay. I think you've gotten enough of that, to be able to kind of put some thoughts out there. So talk to me. What do you think?
Well, based on our last Zoom lecture, that seems like it was not the case at all. we talked and read a lot of things about it being open and plains and not a lot of grasslands at all, or not a lot of forest.
Okay. At least in some areas, there were definitely lots of forest in some places, right? And Kiki, I think one of the things we talked about was, yeah, I don't want you guys to think that it was all grasslands all the time, right? But it also wasn't all forest everywhere. So there was a balance there. All right, good. Thank you, Kiki. All right, anybody else? What was that hypothesis that I presented to you last week that was sort of explained how early Europeans began to move west and why they moved west? What was kind of helping to set that pattern?
Push and pull.
Yeah, the push and pull. Describe that to us a little bit, James.
Is it because, or I know one piece, I might not know the whole thing. I know as new lands where they were able to make over like the mountains and made into new lands, the government kept taking away land from like the Native Americans, which caused pushback, which was pushing back white Europeans from that land, which kind of wanted to make them take it more, if that makes sense.
Okay. Yeah, so push pull, I think I got most of what you said there, James. Basically that with increasing population density, as more and more white settlers were moving to America, they were kind of crowding each other out, right? And so there was this natural tendency for them to be pushed further and further inland because they wanted more and more land and they felt crowded. But what was pulling them was the lure of these already open meadows and open landscapes in places like Northern Virginia and so forth. So they were being attracted or pulled to those places. That sort of flies in the face of what Braun has suggested here in some respects. All right, any other thoughts about this?
It sounds like she just didn't travel far enough west.
Well, you know, what's weird is Braun she was a big time traveler for her day. You know, she was trained and was a faculty member at the University of Cincinnati. She did a lot of field work in Tennessee and Kentucky and Ohio and, you know, all parts of probably the Eastern US. I suspect that, you know, having been born in 1889, she also had access to quite a number of old folks, right, that she could have talked to and asked about the early ways of living. But I also suspect that at the time that she was sort of coming up and being an active as a young professional and a young woman, probably in about the 1920s is when her career really began to take off, in the 1930s and 40s and 50s. During those times, it was at the height of environmental degradation for her generation. And so coming up through the 1880s and the 1890s, 1900, 1910s, all the way up through the 20s, we saw like this real peak in deforestation. Land was getting cleared everywhere. There was industrial logging going on. I think Lucy Braun was deeply affected by just the deep devastation that was happening to our forest. I think that's one thing that influenced her to really think about forest and to study on forest and really focus on them. The other thing is, you know, she was born in 1889, which for, you know, someone who's living in Ohio and having a career in Ohio, that still is like 50, 60 years after most of Ohio's grasslands that had already been lost, and probably 70, 80 years after many of the grasslands of Kentucky have been lost. So I think Lucy Braun suffered from being born just a little bit too late and not being aware of these earlier ecosystems that had kind of vanished by the point that she came around. I think one last thing is, if she explored the early literature, like what people wrote in, say, the 1700s or the earliest 1800s, it doesn't really show in her work. She doesn't really refer to historical literature in her book. She doesn't cite anything prior to, like, 1900, and that's a problem. But the reason I bring that point up is I have run into a lot of scientists over the years who do not sort of don't believe that citing the historical literature is relevant to the field of science. And I would strongly disagree with that, because science as a field, as a discipline, did not really develop in the United States until after the Civil War, until about the time of Lucy Braun. She was probably only the second or third generation of scientists in this country. And so scientists, by and large, sort of missed the first couple hundred years of American history. They weren't here. They couldn't experience it. And so I think it's incumbent upon us as scientists and as people who value science, that if we're trying to write about something that sort of predates scientific thought, at least for the Eastern United States, we have to make sure that we're going back and reading that old literature and citing historical documents and maps. And I think that's one of the faults of Lucy Braun's work, is that she didn't do that. And so then she puts this statement out, which I think is highly misleading and unfortunate. All right, so let's keep going. So in talking about climax communities, this is a map that Braun published in 1950, which shows her concept of climax vegetation types. Focus on the region right over where Clarksville is. What type of forest? Number one, she said basically the entire eastern part of the United States was represented by one type of what she called a forest region. Now, this is significant because it was really Braun who, in part, I think, led us down this road of characterizing all of the eastern United States as a forest type. If you were to go back to the 1880s and 1870s and previously, lots of people wrote about savannas and prairies and barrens and glades. But something happened in the 1900s to where almost no one referred to prairies, barrens, meadows, and glades anymore. People spoke about the eastern U.S. as a forest type, as a forest region. And they sort of abandoned this notion that there were grasslands. I don't know that Braun is responsible for that. She was a highly talented ecologist. But I do think her work of promoting climax communities as climax forest types clouded our abilities to look objectively at what the landscape actually should be. So, for example, for the region around where Middle Tennessee and Clarksville is, what region does she call that?
Western Mesophytic.
Yeah, Western Mesophytic forest region, right? And so what we mean by that is here, this is a region that if given enough time, it will become a forest type. It will evolve into a forest, and it will stay as a forest under climax conditions. And climax here is, and you can look at the prefix of that word climax, CLIM, refers to climate. Under the climate of Eastern North America, with enough rainfall and a temperate climate, she is saying that it will develop into a Western Mesophytic forest. Now, what is that? That is a forest that is largely dominated by oaks and hickories, also with some maple, maybe beech trees. And it's not quite as diverse, though, as the mixed mesophytic forest, which she considered to be the most diverse forest in North America. And you'll notice that's a little bit farther to the east. That's the forest type that is primarily associated with what ecoregions? Yeah. The mixed mesophytic is associated with what would be one or two ecoregions it's associated with.
Ridge and valleys?
It could be a little bit. That's a little bit farther east there, Clayton, into this area shown in blue. So this would be what's to the west of the Ridge and Valley.
The Cumberland Plateau.
Cumberland Plateau, absolutely. And also, what's to the northeast of the Cumberland Plateau?
Is it the Blue Ridge Mountains?
Not the Blue Ridge. Those are on the east side of the Ridge and Valley. So it'd be the Central Appalachians. That's the other mountain range that would be. So a lot of this area of West Virginia here in easternmost Kentucky is part of what's called the Central Appalachians. So that's a region called the mixed mesophytic forest. And in contrast to, I'm going to turn my video off here. In contrast to the western mesophytic forest, that mixed mesophytic region is has a higher rainfall. It's richer, it's moister, it's got a lot more tree diversity in it. There's a lot more Appalachian species that you would see associated with that. And then she goes on to identify some other forest regions. So the oak chestnut forest region of the Blue Ridge over here and parts of the Ridge and Valley. And then you've got an oak pine region of the Piedmont and the southern Ridge and Valley over across parts of the upper coastal plain. And then you've got a southeastern evergreen type down here as well. And so she divides the whole eastern region up basically into these forest types. Another key one would be the oak hickory. And then up here is the beech maple. But what, yeah, what's up?
I'm sorry.
You got it.
Could she possibly have been meaning of the forests that are in those regions, they are largely this type, rather than meaning it is ubiquitous forest?
Well, I think that that's partially true. I think what she basically is saying is that all of the vegetation types, or most of the vegetation is probably a better way to put it, that most of the vegetation types within a given region, if given enough time, are going to develop into this forest region type.
I got you. Thank you.
Yeah. And so the whole premise there is that these are all evolving toward some idealistic forest region type.
I see. Thank you.
Yeah. All right, let's explore this a little bit further. So if we go next to here, this graph kind of explores this in a little bit more detail. I'm sure most of you have seen similar types of graphs, and I do apologize for the graininess of this. I just kind of stole it off of Google Images. It shows this sort of idealized successional pathway. You know, imagine, for example, if you had a fire that completely burned down a forest and took it all the way back to mineral soil or down to bedrock, then you sort of reset the successional clock, right? In the first year or two, you would expect weedy pioneer species to come into that site. By years 3 and 4, maybe it's perennial grasses and shrub, grasses are coming in, wildflowers are coming in. And then eventually, years 5 to 150, you've got these what are called intermediate species. It's going through various stages of succession. Shrubs and thickets are developing, and then small trees invade. And then you've got trees that like a lot of sunlight are able to flourish, shown here by some of these trees that look like pine trees, or in this case, probably spruce trees. And then eventually, notice that it achieves, after about 150 or 200 years, it achieves what's called a climax community. This is part of the problem, though, of this model, is that there's almost no real examples where, certainly in the case of 150 or 200 years, sure, there are vegetation types that might go through this very sort of these various stages of development. But the problem is what happens after 500 years or 800 years or 1,000 years? Rarely do we have enough stable conditions over those kinds of timelines for these ecosystems to stay perfectly intact as a climax type. Basically, something's going to happen. Something's going to affect them. They're going to be affected by a flood, or they're going to be affected by fire, or there's going to be megafauna, or there's going to be people affecting that community, which is going to reset it. So we've largely moved away from this idea of a climax type. Now, there are some other real issues with this model that is depicted here. And this is in Encyclopedia Britannica, by the way, from 2006. What does it do for grasslands? What does it say for grasslands under this model?
Looks like it's saying that they'll be inevitably overtaken by woody plants.
It's exactly what it's saying, right? And of course, this model is regionally dependent, right? So for a temperate region with a temperate climate, we've all been taught that temperate regions with enough rainfall should be temperate forest as a biome type. But that's misleading, because what do we do about our temperate grasslands that we have in North America and Europe, and there's some in South America too? Are we to believe that temperate grasslands are, what's called a seral stage, SERAL, basically just they're just one stage in this pathway of succession that's always destined to become a forest? Does that seem to match what you've learned in this class about deep time? Think in terms of geologic time. Does that match?
I would say no.
Why is that, Brandon?
I just think that things are changing too often for there to be a climax community that is possible, really.
Yeah, that's true. I think things are changing probably too often. At least every few thousand years, enough change is happening to shift things fairly dramatically. I mean, we've seen that just looking at the Ice Age, right? Looking at the Younger Dryas and how quickly that change happened, and just massive amounts of vegetation and biological change associated with that. But back to this point about this model for the temperate region here seems to suggest that grasslands are early successional communities, right? Versus a climax forest, a mature oak and hickory forest, the implication by this graphic is that it is a late successional community. Would you agree with that? Have you guys ever heard the terms early successional and late successional used?
Yes.
Yeah.
Yeah.
So I'm here at this meeting. I'm at a conference in Michigan right now that is the North American Association for Fish and Wildlife Directors. And there's about 1,000 people at this conference. And I guarantee you, if I walk downstairs at the plenary session and I went up to the podium and said, hey, wait a minute, guys, I'm going to interrupt today's session and I'm going to ask a question. I'm going to poll the audience. All right. If I said, true or false, are grasslands early successional communities, or are they late successional communities? What percentage of the audience here at this conference, which is, a bunch of leading conservationists, the directors of every major state, federal, tribal, Department of Defense, nonprofit, they're all here. What percentage of the people in that room would raise their hand and say they're early successional communities, do you think?
Probably most of them. I think I misunderstood your earlier question, Dr. S says. I would agree with you in this case, so I would change my answer.
Oh, I don't know that you need to change your answer. I sometimes ask overly convoluted questions. So, yeah, I think probably most of the people down there would raise their hand. Yes, I think it's true that grasslands are early successional communities. That's what they would say. And I would have too, probably 15 years ago. And I will say this, I think a lot of people in the fields of wildlife management and natural resources, forestry, agriculture, fisheries, those types of programs, most of them have been taught and still believe and still teach that grasslands and thicket communities are early successional habitats. And unfortunately, that is a artifact of the climax community days of thinking. And it's antiquated because we do know that we have lots of examples of old growth grasslands. So that, we have grasslands that are thousands of years old. So this model doesn't account for those very well, for example. Okay. Any questions about that?
Dr. Estes, I do have a
Yes.
question about that.
Uh-huh.
To say that grasslands are really just successional environments that will inevitably be outcompeted by woody plants and forests, doesn't that almost go against natural selection? Like these species would so many grass species would be bound to go extinct because they're just going to be inevitably outcompeted.
I think that's right. If I'm understanding your question, Matthew, help me out with that. I'm not sure I completely understand what you're asking.
Like they're just bound to be outcompeted in any number of these different ecosystems. Like as far as like evolution goes, wouldn't that mean they would just be naturally outcompeted and eventually lead to extinction if what they say is true, they're
Oh.
only early successional
Yeah,
habitats?
I guess the thing that prevents that from happening though is that we have so many forms of disturbance like habitat fragmentation and clear cutting, right? Then most people see these kinds of continual opening up of the landscape so that those early pioneer species have plenty of opportunity to continually get established. So they're not at all threatened with extinction. But I think what people confuse is they confuse that there are those weedy pioneer habitats like, or weedy, there are lots of weedy early successional open habitats, right? A cattle pasture is an early successional community. A clear cut is an early successional community. There are types of, and there are some types, there are other kinds as well. But a tallgrass prairie out in, western Kansas is not an early successional community. They may look similar in the fact that they're open and grassy and have few trees, but that's where the similarities kind of disappear because that prairie has taken thousands of years to assemble and is just as old as the redwood forest or just as old as, some of the most ancient tropical rainforest of Borneo. But yet most people in the field of conservation and natural resources and ecology have always traditionally looked at grasslands, particularly in eastern temperate North America, as a serial stage, as one step in the development of what is supposed to become a forest. So we've always inherently looked at grasslands as just, on the way to becoming forests. We've never really looked at them as fully what they are, which is their own stable ecosystems. But here's the clincher. If you take what has kept grasslands in place for millions of years or thousands of years, and you take those factors away, then yes, they do become forest. So let me ask you that. What are the factors? So under the climate and rainfall that we have here in Tennessee, a grassland will become forest always, unless three things are there. What are those three things that would prevent a grassland from developing into a forest? There could be four
Fire,
things. A fire's one, yeah.
grazing,
Grazing,
Maybe the type of soil.
yeah. Type of soil, what we call edaphic conditions, right? Very shallow, rocky soil. And there's one more possibility really that I can think of. And that would be flooding. In some cases, we have flooding is able to preclude the growth of trees and keep it from going to forest. All right. Let's move on to another concept now, which is gradients are very important. Take a look at this sort of schematic that shows vegetation types on the sides of the mountain in the Great Smoky Mountains National Park. Depending on things like elevation, aspect, whether you're on a north slope or a south facing slope, what landform are you on? Are you on a back slope or a shoulder slope or a foot slope or on a ridge line? What kind of soil moisture do you have? Is it hydric, where you have, saturated with water? Is it mesic, meaning moist, or is it xeric, which means very dry? And then what kind of soil types do you have? Is it clay-based soil or sandy soils or so forth? So all these things act together to influence where specific vegetation types are. And you can see a tremendous amount of variation. And so these aren't defined by very hard lines. They actually sort of grade into one another across these sort of gradient boundaries. And so, for example, up on the top of the mountain, you may have a forest type that's dominated by red spruce and Fraser fir trees. On a north-facing slope where it's more protected, it's more shaded, snow hangs around longer and so forth, you might have those spruce and fir trees that typically grow above 5,000 feet elevation. But on a north-facing slope, those trees that are really adapted to very cold conditions, they may creep on a little bit down lower, even into, say, the 3,700 foot elevation range or 4,000 feet. So just the effective aspect can cause those spruce and fir trees to kind of sprinkle themselves down in and among the high elevation red oak forest type. And so there may not be a clear-cut boundary there. But if you were to go to a south-facing slope where it's warmer and the snow melts sooner, then maybe the spruce fir zone is right at 5,000 feet, or it might even be a little bit higher up at, say, 5,200 feet. So these gradients are dictated by these 5 major factors that I've given here on the right. But we can also see gradients in non-mountainous landscapes. Here's a gradient that we might expect in an open landscape characterized by plains, dissected plains that kind of roll into hills and then eventually become very broken, or what we call breaks. And in this landscape, we would expect prairies to develop out here on the most open plains, where if you were to look down from the top, you would see there's less than 10% total tree cover in this region. But as you progress into a slightly undulating or very slightly dissected plain, you're going to have more places that are protected from fire, more places for trees to grow, and therefore you're going to have trees that typically would be around probably 10 to 30% of the coverage of that region. This is what we would classify as a savanna. Finally, if you get even progressively more hilly, you would expect somewhere between open and closed woodland. And then in the most dissected areas where, in this case, fire is not able to burn, down in really deep ravines and hollows where there are creeks and rivers, you're going to expect those open woodlands to grade into closed canopy forest. So gradients are really important to understand on the natural landscape. Now, all of this has kind of led various vegetation ecologists through the years to recognize what's called potential natural vegetation. And that is to say that, if given enough time, the potential vegetation of a given region will become X. If given enough time somewhere else, the vegetation will become Y. So August Kukler, who was a 20th century vegetation ecologist, a German-American geographer and naturalist, he developed what's called this map of potential vegetation for North America. And one of the things you see here is this is the eastern hardwood forest, which is specifically a very specific type of forest community. So he's saying that pretty much anywhere within this yellow region that the predominant vegetation is going to develop as an oak hickory forest type. Likewise, for the area around Nashville, Tennessee, he said that the primary vegetation type here is what's called a cedar glade, which is an open glade over limestone bedrock. So this just sort of reflects the two different potential vegetations that Kukler mapped. And this is the composite map showing all of North America. Kukler's work still, is often cited in ecological papers, not so much as much now as it was probably when I was in school in the 90s and the 2000s, but it's still relevant. It still has people that cite it and use it. It is outdated, though, in the sense that Kukler, kind of like Lucy Braun, was largely referring to things in this sort of outdated climax vegetation perspective, not really considering the forces of grazing by megafauna like bison and elk, or the forces of fire would actually have on vegetation. In fact, most people in the mid to late 20th century totally dismissed the role of fire in many parts of the Mid-South. It's only been very recently, in say the past 10 years or 20 years especially, that people have really started to think about fire, natural fire, and the role that it would have played over long periods of time. One of the ecologists who was really the Southeast in sort of defining and, giving appropriate levels of importance to fire was an Alabama ecologist by the name of Roland Harper. Harper was trained at Columbia University, an Ivy League school, and later became a professor at the University of Alabama. He traveled extensively across the Southeast and did a lot of photography of natural ecosystems spanning from like the latest 1890s all the way up probably through his death. And he specifically was fond of savannas and grasslands, but he also published extensively on forest. So, for example, he's got a book on that he published in the Geological Survey of Alabama, which is the forest regions of Alabama. So even though Harper was one who recognized the role of fire, he still kind of used that antiquated term of forest regions, which very much sort of is this in reference to the fact that, yeah, Alabama's destined to become, a forest in time. Even Harper missed some of the key grassland regions of Alabama, for example. Now, this is a map that shows one of the more recent sort of model-based efforts to identify the potential vegetation of a region that's called the Central Hardwoods region. So this includes the interior low plateau ecoregion on the right and parts of the Ozarks over here on the left, and kind of where they come together across southern Illinois. And collectively, this is a region known as the Central Hardwoods. It's kind of a conservation region. And in this map, some vegetation modelers have predicted where vegetation of different kinds would be all the way from open prairie and prairie savanna with less than 20% tree cover, all the way up through like glade types shown here in purple. You've got various kinds of open oak woodlands with various levels of open canopies from 20 to 50%, a closed woodland canopy at 50 to 80%, and then on up through the increasingly denser forest, like true forest here in very dark green with a greater than 80% canopy cover. as well as floodplain forest, shown here in sort of dark blue, which we would see along some of the river floodplains. And so these types of maps are helpful for conservation and for us ecologists to kind of understand, you know, what type of vegetation would be predicted at a given region. And so this, again, runs contrary to what Lucy Braun suggested, that everything in the East was forest. Now, it's clear that based on, you know, how much dark green we see here, and how much medium and lighter tone greens there were, and the bluish, that yes, tree dominated landscapes certainly were most common. But we absolutely would have had a fairly high amount of both prairies and grasslands and sparsely treed landscapes as well. And you can see that by these lighter colored areas here. Even these very light colored greens that you see like over here in Missouri and around parts of these light greens in and around Clarksville and Middle Tennessee, these were open savanna regions or very open woodland regions that would have been quite grassy. This map is just a closer sort of a closer up version of the one I just showed you. And if you were to zoom all the way in, you can actually see there's a very fine scaled mosaic here that if you look on this map on the right, you can see how, you know, there are patches of dark forest in here, closed forest in the darkest green, bottomland forest in the blue. These lightest colors represent open oak woodland with 20 to 50% tree canopy coverage. And the medium green shown here is closed woodland with 50 to 80% tree cover. But the point is that there's a lot of heterogeneity within an area of just a few square miles, shown there in that block. There's very few places in this screen on either side that you could go to and say it was all forested or it was all grassland, right? If you take that same sort of size block, roughly a square mile, and lay that down almost anywhere in here, you would be hard pressed to find an area that is all forest or all grassland. And something we need to also recognize is even these models are not always completely accurate. And for example, take a look down here in southern Middle Tennessee. This area is shown as almost continuously forested. And these maps would show what it would have been like prior to European settlement. So probably around 1700 or 1750 is what they're trying to show. But even these maps are inaccurate. We now know from various other forms of evidence. There certainly would have been scattered openings in some places down here. Okay, so let's talk more broadly. Let's step back out a little bit. What are some of the reasons why we need to know community types? Let's talk about that and just sort of brainstorm it as a class real quick. Why do you guys in my class, why do you need to know your communities?
Different community types have different responses to disturbance. They have different nutrient cycling properties. Community composition can change depending on selective forces moving into an area. It's good to know about. There's lots of stuff.
Okay, good, Clayton. Someone else got some different thoughts there?
I know the relevance for me, anyways, working with wildlife is that, you know, I'm going to find wildlife in different community types, and knowing those community types is going to help me with my research later on.
Yeah, absolutely. And you know, for sure, if you're studying, you know, pretty much any kind of species of wildlife, you know, be that small game species like salamander or non-game species, salamanders, songbirds, you know, or game species like northern bobwhite quail or black bear, you know, you really need to know their ecosystem preferences, their community preferences. All right, anybody else have any thoughts on why we need to know community types? And not just community types, but we need to know the dynamics, right? What are the processes and what are the different dynamics of those communities? Somebody was about to answer there. Go ahead.
I would say to understand the history of the landforms and to understand how it supports also the history or the change in plants and animals that have occupied that area.
Yeah, that's really good, Juliet. Absolutely. I think that's really, really important. We need to know how these communities have changed. And I think also the people interaction, right? How they've changed in response to people. I think that's important for us to understand also how resilient are these communities to change? You know, can different ecosystem types, different community types, can they withstand the pressures that we're putting on them as a nation? Can they withstand, you know, a certain amount of pressure from the agriculture sector or from urban sprawl? You know, some communities are better at dealing with that than other types, right? And so I think for the sake of biodiversity and the sake of not losing species and ecosystems around us, we need to understand how these community types, how resilient they are to people. And because one thing's for sure, people are not going away anytime soon, and things are only going to get more fragmented. There's only going to be increasing population pressures and densities, more fragmentation, more disturbance, more invasive species. And we need to have a good understanding of how our community types are doing and how they're going to be affected by, you know, the continued presence of people on this landscape. All right, let's just talk about some other things that come to mind. So number one, it's important to understand which communities are rare and to know that rare natural communities often support rare species. Here's just a quick table of some examples. You know, the last one down here, for example, the Nashville Basin limestone glade and woodland. Excuse me, I meant to say this one right here, the limestone glade streamside meadow. That's a really rare natural community. It has what's called a global rank. We haven't talked much about global and S ranks, but all natural communities are ranked on a G1 to G5 basis. And essentially, if something is a G1 natural community, has a global rank of G1, that means that there are 5 or fewer occurrences of that natural ecosystem on the planet. If something is a G2, then it is known from, I think it's like 6 to 20 occurrences on the planet. Then you can go to G3, you can go to G4, and you can go to G5. So something that's a G5 is represented by, you know, hundreds, if not 1,000 or more occurrences of a given type. Now you can use that same logic with what's called S ranks or state ranks. An S1 species is known from 5 or fewer occurrences in that state. So for this type of ecosystem, this one right here, the limestone glade streamside meadow, that's a G2 community with less than 20 known occurrences in the world and less than 20 known occurrences in the state of Tennessee. So it helps us to understand then, you know, that this is a very rare community type, and we should strive in our planning for our regions where we live. We should make sure that we're not causing the extirpation of these natural communities. Because we have to realize also that, like that community, which is shown here, this is a photograph of that limestone glade streamside meadow. This is shown at Cedars of Lebanon State Park, which is about 30 miles east of Nashville. This is a highly rare community type, but it also is one that supports very rare species like the leafy prairie clover, which is Dahlia foliosa, and the streamside salamander, Ambystoma barbari. So these are just two of probably about 10 or 15 rare plant and animal species that occupies this highly rare natural community. And so we need to make sure that we're not losing these ecosystems continuously because of things like landscape change or habitat fragmentation and habitat loss. It's also important to realize that, you know, our natural communities around us, they contribute in different ways to biodiversity and wildlife. If you take a look, for example, at this scene on the right, this is a pine savanna or pine savanna / pine woodland out in the coastal plain of North Carolina. This particular scene, if you were to lay down a square meter plot, has 52 species inside a single square meter on the floor of this pine savanna. So that's phenomenal biodiversity. So some of our communities, like certain types of savannas or woodlands, are highly biodiverse. Other types of communities, such as certain kinds of swamps and maybe salt marshes, may not have nearly as much biodiversity. And so and then other cases like certain kinds of prairies. For example, there's a prairie in Mississippi near Starkville that has 90 species of bees in one prairie remnant. That's about 100 acres in size. There's far more bees known from that one tiny prairie than any of the forest types in the Mid-South. So because our biodiversity is not using all of our ecosystems equally, we need to make sure we're understanding those types of communities that are naturally very high in biodiversity, naturally high in plant and animal biodiversity, so that we can prioritize those so we don't lose those ecosystems. And of course, it's important that we have natural communities that are functional and that are flourishing, because they provide what Theo Witzel of Team SGI calls groceries on the ground. You know, natural ecosystems provide seeds and cover and the nectar and forage, all the things they need to be able to live and thrive and flourish, to raise babies and to protect and hide themselves from predators. We need healthy, functioning natural ecosystems that provide that full range of resources to both game and non-game species, as well as plants. And that's a key component, is the thing that is creating the groceries on the ground are the plants. And oftentimes, or rarely, I should say, are the plant communities really considered first. But if you can plan for the natural communities from a plant-based perspective first, then you can ensure that the animals will have what they need. But for the past several decades, we've often gone about it the wrong way. We've planned for bird conservation by focusing on, you know, one species, northern bobwhite quail, or one game species, white-tailed deer, or, you know, wild turkeys. Instead, we should be focused on the ecosystems, on the natural communities. And part of what I want you guys to learn is that in order to do that, you need to know what makes up those natural communities. You need to know the trees and shrubs and the wildflowers and the grasses. Now, in an ideal world, sure, I'd love for you to all to come out of this class having being able to identify hundreds of species, but that's not practical. But what I can do is teach you examples of what these natural ecosystems should look like. And we can talk through and make sure that by the time you get out of my class, you have a firm understanding of why the plants are what creates these ecosystems in the first place and creates the conditions necessary for all the animals that need to utilize these places. And so with all that, we need to then have a firm grasp of natural communities. So then we can also understand, you know, what places need fire, prescribed fire, what places need protection from fire, what places need to make sure that we keep their hydrology intact, meaning their groundwater supplies. What places do we need to make sure we restore the natural flood regime, you know, along rivers? Are there places that we need to bring back major grazing animals, for example, to be able to be healthy and to thrive? all that depends on having a strong knowledge of natural ecosystems. Let's talk about the review of major vegetation classes. So what we mean by this is it's just another word of saying, let's take a look at physiognomy. That's basically a word that characterizes the structure of vegetation. First of all, we've got these major classes is what we call these. So forest and woodland would be a class of vegetation. That's one physiognomic type. Let's take a minute just to kind of go through these quickly, and then we'll sort of get deeper into the definitions and sort of what makes these different kinds of communities, what makes them special as we go through the rest of the PowerPoint. So we have a forest, for example, and this maybe seems a little bit intuitive, like, yeah, of course I know what a forest is, but do you really? Forests are very similar to woodlands, very similar to forests, but they actually sort of function in different ways, and they can be divided, sort of in some respects. But forests, as defined here, are going to be essentially closed, canopied, tree-dominated, generally moist, sometimes dry, sometimes wet. They also are going to have a lot of layering in the canopy. So I'm really going to make sure to hammer you guys on this. So make sure you pay attention on this section. They're going to have layers. You're going to have a canopy. You're going to have a subcanopy usually. You may have small tree species that form the subcanopy. You often have shrubs in the understory as well. And you have, oftentimes in our region, you have a lot of mosses and liverworts and things that you see here coating the rocks. You may have ferns, and you may have forest wildflowers, especially ones that bloom in the spring, what we call ephemeral spring wildflowers, sort of very short-lived. And then most of the wildlife in sort of these true forests are forest-dependent species. You may have various types of spiders that need heavy shade, or songbirds like cerulean warblers, salamanders that live under some of the rocks, various types of centipedes and millipedes and forest inhabiting ants. The whole assemblage is geared toward life in a fairly densely forested ecosystem. That is a forest. And one other thing about a forest is they typically occur in fire-protected landscapes. So they're down in the ravines and in sort of bottomlands, or along back slopes and foot slopes and toe slopes. And of course, there are dry forests as well, which may be a bit more exposed topographically up on slopes and ridge lines and those kind of things. They do not need fire in most cases, at least in the way that I've defined it here. They are often mesophytic communities. They're very moist. Fire may return to these communities longer than every 15 years or 20 years. In some cases, fire may be absent for greater than 50 to 100 years, or they may be absent for really long periods of time. So the key there is, well, there's several features there, but we'll move on unless you have any questions about what constitutes a forest. Any questions on that? Okay. Next up is a woodland. Woodlands tend to have a moderate amount of tree cover, anywhere from like 30% to about 80% tree canopy cover. So imagine if you're looking down on top of the trees from the sky, and if you were to draw a square and sort of put circles around the tree canopies, 30 to 80% of the ground space would intersect with, or would be covered up by, the tree canopy above it. But notice that there's enough sunlight coming through the gaps in the tree canopy that there's sort of dappled light on the floor. You can actually see it here. You can see the dappled sunlight shining down. So you get these little sun pockets. Because of the higher amounts of light, you get grasses and wildflowers typically on the ground layer, on the ground floor. And this promotes a higher incidence of wildfire. There's more fuels to burn that what we call fine fuels. And so typically woodlands are kind of open, and they usually have sort of a two-tiered structure. You've got an open tree canopy above, and then mostly a grassy layer down below. There's not a lot of subcanopy development. There's not a lot of, small tree development in woodlands, although some types do. And the shrubs that are here usually might be kind of confined and low to the ground. They may be 3 or 4 feet in height. So they kind of be easily mistakable as being part of the ground layer. So woodlands tend to have a pretty ample amount of wildfire, usually every probably 5 to 15 years fire return interval. And then there are some types of woodlands that are kept open not by fire, but because of very stony soil or heavily clay-based soils or sandy soils. So edaphic factors can maintain certain kinds of woodlands too. Okay, so forest and woodlands are kind of in one group. Let's now go to the broad category of grassland. Here we would have another community that includes trees, but this one would have the least amount of trees. This would be a savanna. So typically 10, 20, or 30% tree canopy cover. Otherwise, pretty much prairie-like on the ground layer, dominated by grasses and wildflowers or small shrubs, but a very, very open tree canopy. And by the way, there's a lot of interplay between savannas and woodlands. That it's not a real fine break. There's a lot of intergradation between those two. But there's a pretty clean break relatively. I don't even know if that's accurate. I would say that woodlands and savannas are more nearly similar to one another than are closed canopy forests, the first group we started with. One of the things that characterizes savannas and woodlands is the high incidence of species that need sunlight. And so for that reason, they tend to have really diverse wildflower displays and native grass layers, especially in late summer and early fall, which is a different season that we typically expect with forests. Most of the biomass in forests tends to develop and flower in the spring. Prairies are the most open community that we have. Typically less than 10% tree canopy cover. The trees tend to be isolated down along the streams and small creeks. This is a vegetation type that's dominated by grasses and wildflowers, and but there are also some shrubs in these ecosystems as well. Fire is thought to be pretty prevalent, both in savannas and prairies. Typically, sometimes every 1 to 5 years, wildfires come through. Both savannas and prairies, as well as woodlands, can have embedded smaller communities in them, like rock outcrops or wetlands or small vernal pools or other kinds of small scale communities. Another kind of grassland is found at high elevations in the mountains, particularly in the Blue Ridge Mountains. It's the only place, in fact, in eastern North America where we get this type of grassland called a bald. This is up on the top of the Blue Ridge along the Appalachian Trail. And I mentioned this kind of ecosystem back when we were doing our ecoregion tour. And this grassland here, by the way, is anything but an early successional community. This is definitely an example of an old growth grassland. These grasslands have been open since the Ice Age. And so these are characterized, balds are characterized by being elevated, usually above 4,000 feet elevation, sometimes over 6,000 feet. The grass dominated, lots of wildflowers. They also have lots of shrubs as well. These are communities that are found in cold ecosystems, relatively speaking. So they're adapted to high levels of snow, cold temperatures in winter, shorter growing season. Now they do not have a true timberline that you would expect in an alpine tundra zone. So, if you look across at that mountain in the distance, for example, that mountain summit is actually higher than the mountain that this photograph is taken from. So trees can grow here. It's just for some reason they're not here. This has been a big subject of consideration in the past by ecologists. The leading theory on that is that these grasslands are still open because during the Ice Age, these were alpine tundras. And that those tundra would have had permafrost soils that were frozen that would have precluded the growth of trees. And that the tundra grassland vegetation basically persisted all the way up into the modern day. And so the fact that trees don't actively grow on the spot is probably just a function of the fact that these grasses provide such an impenetrable layer that unless something disrupts that, it's very difficult for trees to move into and get established in this grass layer. So the fact that it is not converted to forest, even since the Ice Age, 15, 20,000 years, is a testament to how some grasslands, not all, but some grasslands can be very resistant to infiltration by forest. Other grasslands, not so much. They're very easily converted from grassland to forest. The last thing I'll say about this is that balds as a type of vegetation occurring in the temperate northern hemisphere are really only found in 3 places on Earth. Here in the southern Blue Ridge Mountains, in the coastal mountains of Oregon in the Pacific Northwest, and there's a limited area of grass balds in Romania and Poland in Eastern Europe. All right, any questions so far about those types of ecosystems that we've covered? Okay, let's go now to herbaceous wetlands. So these are wetland communities that are dominated by grasses and sedges and rushes and forbs. That term forb is F-O-R-B. Basically means any kind of perennial wildflower or annual wildflower. This first type is equally a grassland type. We could have actually just put it in that last section we were dealing with. And these are called meadows, and these are specifically grasslands that occur usually along stream floodplains. Beavers were probably part of the reason why they exist over millennia. But they're also wet. They have boggy soils with saturated soil from groundwater or from flooding from adjacent streams. And they're oftentimes very, very diverse. So this is probably one of the most diverse grasslands in all of Tennessee. This is over about 30 minutes south of Cookeville, Tennessee. And there's a little small stream that flows through it, which sort of twists and winds its way through. But this is a meadow type wetland, and it's also a grassland. Marshes, on the other hand, are depressional features. So they are places where there are topographic depressions, like a basin or a sinkhole pond. Water collects in those spaces, and typically the water stands throughout most of the year, except during the dry season. And you can have grasses and sedges and rushes or forbs that are emergent, which means sticking up out of the water. And so this is a pretty characteristic of marsh vegetation here. There can be some woody plants in marshes as well. Typically the woody plants, if they dominant, then we would refer to it marsh, but as a swamp. Another type of herbaceous wetland is a very small type called a fen. And these are related also to bogs and seeps. And so there's really not a really good classification for separating fens and bogs and seeps, but just suffice it to say These are small communities that typically are the size of just a few dozen square meters, maybe the size of your house at the most. Rarely are they a few acres in size. They typically are dominated by sedges and rushes and grasses and forbs that need wetland environments. Usually there are also some shrubs present as well. You can see that this fen is surrounded by a forest and woodland type situation. And oftentimes these are directly associated with groundwater seeps. So there's the water from the nearby slopes sort of percolates out and flows across the slope, creating a permanently waterlogged small type of wetland that we call a fen. Okay. Seeps are very similar, but they tend to not have as much soil development. If you go back and look at this example, you could walk on this. It's kind of boggy. You could sink down. You could take a soil core and probably go down anywhere from a few inches down to, perhaps a few feet, depending on how deep the fen is. They tend to have very mucky soil. That the soil has a very slimy or texture to it. Sometimes it even has peat moss in it, where the conditions for decomposition are so poor that the vegetation doesn't really break down. It's very rich in organic materials. We talked about that when we went through soil types. Who remembers the soil order that is predominantly a organic soil? Anybody remember that?
The mollisol?
Not a mollisol. Those are the prairie soils. They are rich, by the way, they are rich in organic, they are rich in carbon, which makes them very black. But in terms of this soil order is very rich in, they're very black, very brown, and they are composed mostly of very poorly decomposed fibric materials of mosses and plant parts.
Humus?
You're close.
About
Humus.
histosol.
That's it. Clayton's got it. Histosol. Yeah. Yeah. Basically, and key in that humus layer, if you were to deepen that out into a pretty thick layer on top, that sort of would form what we're talking about. Good job, Clayton. Histosol is the name. Seeps, by comparison, tend to be small patch communities, just a few square yards, a few square meters, sometimes larger, oftentimes very shallow soiled over bedrock. Here you can see there's a seep coming down over the slope. Fairly little vegetation in this particular example. It is surrounded by a woodland or a forest, depending on how you classify that. They can also be rich in mosses and liverworts and tiny plants that we call bryophytes. Very important to salamanders and a variety of types of amphibians. Okay. All right, next down we'll go to what are called woody wetlands, or wooded wetlands, another way to put it. These are basically, these are swamps. Swamps are wetlands that are tree dominated, where the trees tend to grow out of standing water, at least the water standing for part of the year. Like marshes, swamps tend to be associated with topographic features, topographic basins, that is. So they may be in old oxbow lakes or depressions, like an old channel scar of a river floodplain. They may be in a sinkhole pond. You can have a swamp. And you can have swamps in this case, which are tree dominated, and you can also have what are called shrub swamps, which are shrub dominated, otherwise very similar. So here's an example of a shrub swamp. Very frequently, both swamps and shrub swamps. Some portion of this wetland may also have a section that is dominated by grasses and sedges and forbs, in which case that would be a marsh. And so they often play together in sort of fun little ways there. Now, there are other kinds of wooded dominated wetlands that don't have standing water, but rather they have very saturated soils. So for example, about a couple hours south of Clarksville in the Western Highland Rim, there are these ravines that in the bottoms of the ravines, the groundwater just sort of percolates and it saturates the entire bottom of the ravine. And so certain types of trees, which are adapted to growing with their feet wet, their roots wet, are very successful at being able to grow in these kind of habitats. And there's also a lot of shrubs in these habitats, which are adapted to wetland soils. There may be very deep layers of peat moss. There's lots of ferns. There's certain types of wildflowers and sedges that grow in these kind of habitats. Now, if you look behind this slope back over to about where I'm indicating with my cursor, that's where the slopes begin to pick up. And there's a very distinct zone there where you go from the wet bottom of the ravine to a very dry slope. And so you can have species on that slope in the distance that are never found in wetlands, growing right adjacent to species that need boggy, permanently saturated conditions. So these types of conditions where it's saturated are called seepage forest. And if it's open with a semi-open canopy, then we would call it a seepage woodland. Now, in this case, I would call this a seepage forest because it's got an 80% or more covered canopy here. But if it was in that 30 to 80% canopy coverage, we'd call it a seepage woodland. In the bottoms of a lot of our creek valleys, particularly on floodplains of larger rivers like the Cumberland River and the Red River, the Duck River, the Buffalo River, this is where we find a distinct type of bottomland forest. Sometimes you will hear this referred to as a bottomland hardwood forest or as a floodplain forest. A lot of these forests have been really hammered by deforestation over the past couple hundred years. So when we see these, they typically are not in too great a shape. These are sometimes well drained, but they are subjected, meaning that they have very deep, fertile soils that are very well drained. Others, though, may have very poorly drained soils where there's actually what's called a high water table. If you were to go into this forest and dig a pit down, say, a couple feet deep, you would instantly see the water begin to collect in the bottom of that hole because the water table is so near the surface. So while you might not see that water right at the ground level, if you just dig down a foot or two, typically you'll see that there's a lot of water in the soil just below the surface. So many of these species, certain types of bottomland oaks, green ash trees and sycamore trees, certain types of bottomland maples, are very much adapted to having their feet wet and growing in these bottomland conditions or floodplain conditions. They also are subjected to frequent flooding from the adjacent rivers that they are adjacent to. So think about the flood of 2010 when the Cumberland River rose 20 or 30 feet. They're very used to that occasional flooding, which keeps these bottomlands open or keeps them flooded. Now, sort of the reverse of bottomland forest or floodplain forest are these types of periodically wet tree-dominated ecosystems called flatwoods. These typically occur on sort of high landscapes like the top of a plateau or the top of an open plain or somewhere that's not in an active floodplain. Typically, these are dry communities. Throughout most of the year, flatwoods are really dry, like in, say, June, July, August, November. But then they become very wet in the winter months and into the spring months. And part of the reason for this is that they have a very dense clay layer that's just a few inches below the surface, sometimes 2 or 3 feet below the surface, called a hardpan or fragipan. And that very dense clay layer restricts the permeability or the drainage of the water. And so it just kind of sits above that clay layer and makes the conditions while it's in the rainy season, like say in April, it makes that very, very saturated. And so here you can take a look at this. This is kind of an early spring photograph. And you can see this sort of dark blackish staining right here in the lower right, which is one of the areas where the water is saturated and is kind of pooling at the surface. And that soil is very wet and saturated, a little pocket of it. It's also very telling that if you look over here, there's a root ball from where a tree has completely been upended. And behind it has created a ball, a hole, and that hole is completely full of water. It's like a small vernal pool. And that tells you that it's got a very high water table, that the water is very, very near the surface here. But because that fragipan's there, when it gets to the really hot months of, say, June, July, and August, all the available water in the upper 10 to 15 or 20 inches of soil completely dries out. So these communities are what we call hydroxeric. They go from hydric, means wet, to xeric, which is really dry, all in the same year and sometimes even in the same season. So flatwoods are a type of wooded wetland as well. Next, let's go to various kinds of what we call rocky ecosystems. There are things like cliffs, right? Pretty vertical, sometimes with ledges. There are even some cliffs that have enough soil development on the face of the cliff to where it can actually be a very steep prairie on the cliff face itself. Some cliffs are really dry, some cliffs are saturated and dripping wet with water, and so you can have what are called seepage cliffs, for example. You can also have cliffs that are adjacent to waterfalls that are continuously prone to this mist that comes off the waterfall and that sort of continuously bathes the cliff in water vapor. And those are called spray cliff communities. Those are highly rare and oftentimes support species that only grow on spray cliff communities. We have glades. So these are rocky desert-like grasslands found in this region, that very shallow rocky soil, usually gravelly. There's bedrock oftentimes within just a couple inches of the soil surface. Almost always the bedrock is less than 5 inches underneath the soil. Sometimes the bedrock is exposed. It forms outcrops that are very distinct. In many ways, a glade is kind of like a flatwoods. These are hydroxeric communities. In the early spring, when the rains fall, in winter and spring, that the water can pool up on the surface because it can't drain because there's a continuous layer of bedrock right underneath the ground. And then as you get into the drier months, all that evaporates and it becomes bone dry. So you can go from having wetland plants and wetland salamanders living on open glades to having bone dry conditions with cactus and cedar trees and yucca plants thriving during the hot part of the season. And so some glades are home to, desert-like species like tarantulas and collared lizards and a whole host of species that are kind of more at home in parts of New Mexico, Texas, and Arizona. Any questions about glades or anything we've talked about up until now? Okay. And glades differ depending on which type of rock they form on. So you can have glades on shale, glades on limestone, sandstone, on granite, all of which have different properties and different species. They can be acidic, they can be calcareous. So glades take on a lot of their properties based on what type of what type of bedrock they form on. Likewise, we have barrens. Barrens are typically sloping, rocky, glade-like grasslands. They tend to have more of a deeper soil that typically is, yes, they do have some bedrock exposures as you can see right here, but typically they have a little bit deeper soil than a glade. That deeper soil typically can be somewhere between 5 and 10 inches deep, sometimes a little bit deeper, sometimes shallower. It's often gravelly, very prone to drought. And because it's up on a slope, sometimes a very steep slope, the water doesn't stand on these kinds of landscapes like they do on glades, right? On this glade, the water just sort of sits and forms into these pools, like vernal pools. But in a glade, the water drains down slope. So these communities are pretty much xeric, and that's Xeric. They're pretty much xeric communities year round. They can get a little bit saturated in the spring months, but not anything like a glade. They do oftentimes have old trees on them. Some of the red cedar trees that you're seeing here are anywhere from 100 to 250 years old. So they can support old growth trees on these landscapes. Both glades and barrens tend to be community types that sometimes you might expect them to burn frequently, but one of the challenges of glades is they have so little fuel that fire can't really burn across that rocky surface very well. So glades really don't need much in the way of fire, and they're pretty resistant. The open glade itself is pretty resistant to invasion by trees, but it's that deeper soil around the glades and around the barrens, which is really susceptible to becoming invaded. All that red cedar you see in the background there has probably come in recent decades or recent past century and a half. And so while the glade itself has remained intact, it's the glade margins that have changed drastically. Another type of rocky community are what we call outcrops. And outcrop is a funny, it's a term that I can realize there's some confusion here because, some people might say, well, this exposure of rock right there is an outcrop, or this patch of limestone right here is an outcrop. And that's true. They are places where that rock crops out at the surface. In this sense, though, outcrop is used to kind of denote a rocky type of ecosystem that is grass or shrub dominated, that's usually on a mountain ridge top or a summit, like you see here, for example. This would be an outcrop community. And then the last rocky community that I'm going to bring to your attention are what we call block fields. And these are places high up in the mountains typically that are basically just massive expanses of very loose boulders, sort of scree slopes and block fields, boulder fields. They go by different names. But here in Tennessee, we see these in just a few places. You can see one up in the distance, way up here in the upper left as well. These don't have a lot of vegetation on them. Sometimes they can get tangles of grapevines sort of growing across the surface, or sometimes there might be some young birch trees popping up or some ferns. But generally speaking, there's not a whole lot of plant material that lives out in these open block field communities. Okay, now we're going to go to riparian ecosystems. Riparian basically are those that are along streams and rivers. So we might have things like sandbar communities sort of in the upper left. Here's a sandbar community in the lower left as well. Gravel bars, mud flats that you might see along rivers. These are all examples of riparian zones. So they're pretty much deposited because of the waters of those streams that they're located adjacent to. A related type of riparian ecosystem is called river scour, and these are much more highly stable. And here's what I mean by that. This sandbar that you see over here on the left, because of the nature of how big rivers in these big floodplains are constantly changing their course, at least they used to before we messed up the normal hydrology of rivers. Then what that means is that every other year, or sometimes every year, when that river floods, those sands get reworked, or those gravel bars get reworked, meaning that sandbar might not be there next year, or it might not be there in 5 years. That river course might change entirely. If the Mississippi River decides to cut a new channel, it could abandon that and form an oxbow, and the river could change location. That's not going to happen, though, down in this deep river canyon, like here at Big South Fork National River and Recreation Area. This river is very much set in its course. It floods year after year in the same location. And if you look along its banks, there is a unstable sand-dominated riparian community over here on the left, which is subject to a lot of harsh effects from flooding. And the sands that are deposited there are going to be constantly shifting. So that means then that that's an unstable community type. It's going to be dominated by weedy species that tend to grow in very rapidly and have fairly short lifespans. And because they know that the conditions are going to change, very quickly from year to year or every 5 or 10 years. In contrast, the species that are growing over here on this side are very stable. It looks highly disorganized and highly altered, and it is, but this is a very remarkably stable ecosystem. And it's different from the forest that's just upslope beyond the flood zone. And it's different from the sandy bank that you see over here on the left. So these are what we call river scour, and these are communities that are very much adapted to high energy, devastating floods, and they're dominated by species that are very long lived. So there's a lot of old growth trees in here, for example, that are definitely able to withstand getting knocked down and growing in contorted positions. There's a lot of old shrubs in here that might be hundreds of years old. In contrast to the types of grasses and wildflowers you see, over here you might have grasses and wildflowers that are annuals. They bloom once a year. I mean, they grow from seed once a year and then they die because they're adapted to just living in highly unstable conditions. Over here, the wildflowers and the grasses are very stable, long-lived. An individual clump of a fern or an individual perennial wildflower may live 50, 60, 100, 200 years. And so they are very long-lived plants that thrive in these river scour environments. This is the type of ecosystem that's poorly known. Earlier this year, Theo and I published a paper in the Natural Areas Journal describing the river scour ecosystems of Eastern North America. They're pretty much undescribed. It's kind of neat to be able to sort of make our mark on describing a new ecosystem. That last section was pretty important because we kind of went through an overview of major types or classes of ecosystems or natural communities. Now what we want to do is sort of switch gears and take a look at how do we actually describe communities? What's that part? What's that process look like? Determining which processes are most important in shaping community pattern requires that we be able to describe these communities. And there's basically two sets of properties. Number one, we're looking at the relative number and relative abundance of species. So that's a big fundamental part of community description and describing communities. You got to know what plant species especially makes them up. And that's what we're talking about here are plants, is the way that communities are determined. And then secondly, which is kind of what we've focused on in the past few slides, is the physical structure. Does it have a forest structure or a woodland structure? Is it a fen, or is it a meadow, or is it a prairie? Those structural components matter a lot. And then all those things together, again, are going to influence other kinds of things like which types of animal species are in these communities. Okay, another thing we need to talk about is the concept of natural communities versus cultural or cultural vegetation. So there's a few different terms that are used here. Sometimes you'll hear people in conservation say, well, what are you trying to go back to? Are you trying to like restore back to some point in history? Pre-settlement is oftentimes used in conservation as a sort of lofty goal to try to go back to. And that essentially would take it back, depending on where you are. In our region, it would take it back to roughly the 1770s or 1760s into what the conditions were that we had then. What does pre-settlement get us? Well, it does not assume there were no people, right? Because there certainly were Native Americans, But it does get us back to a time when we still had natural processes operating by and large in most places in the landscape. We had fire operating, we had bison, we had elk, we had big carnivores like red wolves and mountain lions. And of course, you know, it's not the same date depending on where you go. If you go to Florida, you got to go back a little bit farther because you had, you know, earlier periods of settlement. If you go to the Atlantic coast, you know, that's a different time period than say somewhere like Arkansas, Missouri. So pre-settlement sort of assumes, you know, natural conditions, natural processes, natural forces are still operating. And that's almost impossible to achieve in most regions today. Then there's natural or semi-natural vegetation. That's mostly what we're talking about. What we're concerned with in this class is describing the natural vegetation of a region. What are the natural forest types and natural grassland types? And oftentimes we don't really have great examples to look to anymore. We have what are called remnants of those vegetation types. And then we have, and oftentimes looking down in the bottom left, well, before I go there, so what keeps a site in a natural or semi-natural state? Well, we don't have Native Americans managing the land as we once did in most places across the Southeast. Most of the current inhabitants, the white settlers, or the current people who live on these lands, don't do things the way that Native Americans did them in terms of land management. Very different in terms of how we manage land from indigenous land usage and indigenous knowledge. That's not to say that, you know, we don't have natural vegetation anymore. We do. And so forests, for example, are somewhat the easiest to deal with because most forest types, a lot of them, you can just leave them alone and they'll be in fairly high quality shape if they're indeed a natural type of forest. They may be subjected to invasive species invasion, which is degrading them. That's certainly one big thing. A lot of well, not a lot, but in some places today, for example, on some of the quail plantations in South Carolina or Alabama, these very large farms that are managing for a particular game species, the owners are and the managers are utilizing things like prescribed fire, which keeps those properties looking sort of like they did a couple hundred years ago. So by using fire or by using other kinds of forces, you know, maybe bush hogging, for example, or maybe even a better example would be cutting a prairie by taking hay off of it once a year. So haying a prairie can keep that prairie in a very good state, for example, but not if you cut it twice a year or 3 times a year. That's taking it probably too much. So we have a lot of natural and semi-natural vegetation that remains. Well, we have some that remains in patches. We have a lot more forest types naturally and semi-natural than we do other types. The grasslands especially have been hammered and have sustained losses of mostly more than 95 to 99% of our grasslands are gone. So what's left then is what we see in the bottom left, kind of just a lot of degraded remnants. You know, grasslands that are barely hanging on, they're covered up with invasive species, but there's still enough natural qualities about it to identify it as a remnant of what used to be. And so some of these can be targeted for restoration, and maybe we might need to come in and use more fire or bring in herbicides and very selectively remove the invasive species. Maybe we need to come in with chainsaws and selective herbicide and remove the wrong trees so we can keep the right trees. And then you have cultural landscapes, things like cattle pastures and croplands and urban lands, which are so heavily transformed from the way they used to be that nothing natural remains. You know, oftentimes in these, the only thing natural about them is that they're green, they have sunshine, they have the wind, and that's about it. They don't have their natural animal communities or the natural species that are needed. And their natural processes have been completely interrupted. Okay. Now let's talk about patch sizes of different types of communities. There are sort of four major kinds of patch types. Some communities are naturally very large and expansive, and these are what we call the matrix communities. Things like a given type of woodland or a certain forest type can be a matrix. If you're in the Great Plains, the matrix community there is tallgrass prairie. Within the matrix, then you may have large patch communities. And by the way, matrix communities can be, in the order of many square miles in size, or tens or hundreds of square miles in size. Large patch communities typically are, a few thousand acres or several hundred acres in size. Again, these can be certain forest types, they may be certain grassland types or swamps. Small patch communities tend to be on the order of just a few dozen acres or smaller, down to just a few acres. And then linear systems or linear types oftentimes are found along streams, such as river scour communities or riparian and floodplain forest. Now we can, ideally, vegetation is mappable. So we can actually put this into GIS and we can determine where are the various types of floodplain forests? Where are the grasslands? Or where were they, right? If we're looking at potential vegetation, we're kind of looking back in time at where they all used to be versus actual existing vegetation, which shows what everything is today. So many cases, anymore, we have crops, but so we can look at existing vegetation, it's going to be a crop field. But if we're looking at potential vegetation, we're looking at it as it would have been, say, 200 years ago. This is a map that shows an area just over East Nashville. You can see kind of divided up into various types of units here, various types of forest and woodlands, various types of open, natural, or semi-natural habitats, such as scrub or pasture, hayfields, open water, fresh water, open non-natural habitats like row crops, developed open spaces, low intensity developed areas, and medium and high intensity developed areas. These could be places like strip malls and parking lots and vacant gravel lots, or some type of urban space. Okay. Another issue that we need to talk about is the issue of scale. So in this particular scene in the upper right, the larger, let me ask you a question. What would the matrix community in the photograph in the upper right most likely be? And just in general terms.
Could you restate the question for us? I'm not quite sure I understand what you're asking.
In the upper right, if we're using this sort of the diagram from here, where we defined what a matrix community is, right? What would the matrix be in this upper right photograph? And just think about the classes that we went through earlier, the classes of vegetation. What's the matrix in this landscape, in the entire photograph?
I mean, I'm guessing barren.
Oh,
There's
great.
some stuff in the chat there.
Oh, stuff in the chat. Yeah, sorry, I forget about the chat. Okay. Somebody says forest with a barren in the middle. Good job, James. And Ryan also says forest. Okay, good. Yeah, so the matrix is probably a forest. It might be a woodland. Maybe it's a woodland that, maybe it's a forest that has been fire suppressed and is thicker and denser than it should be. So it should be a woodland, but it looks like a forest, if that makes any sense. So anyways, the point there is, yeah, forest and woodland would be what's in the matrix around the background. And then James, you said it right, that the foreground, all of this would be a barren, okay? now we have this little issue of what I've shown here in this white polygon. What would you call that? Anybody? What would you call that little opening right there? Well, you might not call it anything. It certainly is an exposure of bedrock, right? And in this particular case, it's a type of bedrock called dolomite, but it's a small, very small rock outcrop or bedrock exposure within a barren. Now, the question might be, would it be large enough to give it its own designation as a glade, for example? It is kind of flat. While the rest of that is sloping, this little bit is sort of flat. But at some point, you have to define things in terms of scale. And there is a point at which it's sort of ridiculous to try to split this out, right? And also, if we were to lay down some square meter blocks, let's say, what we might determine here is that this is only about 5 square meters in size. You know, you could put down roughly 5 1 by 1 meter square blocks within this. It's really kind of small. So typically, for the sake of community classification, anything that small of a scale is typically sort of considered to be just variation within a larger community type. So we wouldn't really look at that as a distinct glade community. We would say that that's just a small exposure of bedrock within otherwise an open barren. Now, this is not universally accepted. So for example, if you go to Missouri, one of the challenges with trying to use single terms is that while I might call that a barren for this class and in this region, a ecologist in Missouri would call this entire site a glade, or someone in Texas might call this entire site a prairie. So you should know that the terms that I'm giving you to recognize these distinct categories are not universally accepted. One of the things that SGI is trying to do is bring more sort of nomenclatural consistency to defining these communities so that we can know what we're all talking about in conversation. So with that, let's take a look at a larger plot of land. So typically 100 square meters is kind of the minimum cutoff. Here you see a plot in the lower right that is 10 meters on each side. It could be a 5 by 20 meter rectangular plot. Typically, if something at that size, that's sort of the universally or sort of the accepted sort of minimum size for a given natural community. If something is roughly 100 square meters or larger, then we attempt to define that and to describe that as a distinct community type. Okay, so the opening that you see at the bottom, that large bedrock expanse, is definitely a glade. It's bigger than 100 square meters, and it has its own set of unique characteristics. The small glade-like opening in the top, though, we would just view that as an inclusion within a larger, different type of community, in this case, what we're calling a barren. Now, describing vegetation is a skill that takes a lot of work and a lot of expertise to develop. Let's just go through quickly some of the kinds of information that one would typically need to do a good job of describing a given type of natural community. Okay, so here is just sort of a mock-up. One of the past times when I taught this class, I had my students go through and actually prepare written description. So they had to basically write one of these for a given type of natural community. One of my students who now works for the Office of Kentucky Nature Preserves wrote this particular description for this kind of natural community. So first of all, we've got Southwest Cumberland Plateau escarpment, limestone grassland. So this tells you a little bit about, and we would call this a barren today. This tells you where it is. Southwestern Cumberland Plateau escarpment is in the name. Limestone is part of the name. That tells you a little bit about its geology, and the fact that it's a grassland is one of those grassland types. Some other details that are here are the fact that we have its global rank and its S rank provided. So this tells us how rare it is. Now, typically, natural communities don't get these codes of endangered and threatened like you see here. So that's a little bit of an error that I don't mean to propagate. But we definitely use global ranks and S ranks to rank natural communities. We do not use terms like endangered or threatened or imperiled for natural communities. I think we should, honestly. I think we should have an Endangered Species Act equivalent that focuses on natural ecosystems. It's honestly kind of stupid to me that we have put all this focus and energy around protecting individual species in this country, but yet we don't focus on the ecosystem, which is really what matters. Next up, we want to know, what are the synonyms? Like, what would other people, other researchers or past researchers or conservationists, what would they call this community type? And so here we've got some different synonyms. So NatureServe would call this a central interior highlands, calcareous glade and barrens ecological system. Pat Lawless, who was a PhD student who got his dissertation in 2006, calls it a xeric limestone prairie. And Dr. Hal DeSelm, who's retired late professor from the University of Tennessee, called this a cedar barren. So these are some of the different names that someone would give this ecosystem. This next statement is, and the accompanying map in the upper right. Let's look at the map first. So this shows where there are known occurrences of this community. Now, ideally nowadays, we'd have this be geo-referenced, so you could zoom in at this and see it. You know, if you wanted to zoom all the way in to where you could see in different layers, like a topographic map or an aerial photo or satellite image. Sort of like those images in the lower right there. You'd want to be able to visualize where these ecosystems are according to different base layers. There's a simple description here. It says southeastern Middle Tennessee, parts of Franklin, Coffee, Grundy, and Marion counties, northeastern Alabama, and Madison and Jackson counties. Tennessee examples are mostly found on the dissected western escarpment of the plateau, but a couple of examples occur in the Sequatchie Valley, and that's showing this one over here, for example. So these are helpful statements to have because they tell you kind of what the distribution of that community type is. And then, of course, we might have these photos, like I said, that show it in different perspectives. We might then also have a vegetation description. This tells us kind of what to expect if we were trying to describe this to somebody. It's a small patch community. So that tells us a lot there. We've already kind of covered. It's dominated by perennial grasses and forbs. So that's an important distinction. It occurs as small openings among calcareous, oak, hickory, juniper, woodland matrix. Limestone bedrock is near or at the surface. Outcrops may be abundant. Small limestone glades may occur as inclusions within this community. Vegetation height may range from 0.1 to 1.5 meters. That tells you a little bit how tall the vegetation is on the ground layer. And it forms a relatively dense perennial grass-dominated ground cover. There are some physical attributes here we might want to look at, such as the ecoregion is listed here, Cumberland Plateau Escarpment. What type of landform it's associated with, such as limestone benches. Some are associated with gaps or ridge tops. They are associated with a variety of aspects, different slope exposures. 1,080 feet up to 50 feet above sea level. Slopes range from level to gently sloping. And then there's some things in here about the soil types and how big the average example is, the type of geology they form on, like Mississippian aged limestone of the Monteagle Formation. And the soils are mostly well-drained, calcareous, silty clay loams. So a lot of the information that we've kind of covered in the early part of this class, we're beginning to tease that out and offer that as part of this physical description. So you see how those attributes are really important to describing communities. Then we have some things like natural processes. The present examples of this community are likely edaphically controlled. So that means that they're controlled by shallow bedrock, shallow soils. The shallow soils combined with shrink swell clay preclude abundant tree and shrub cover. Fire also probably helps to maintain the openness of these communities and would likely have burned in from adjacent woodlands across the perennial grass dominated ground layer. When fire was more frequent, part of the landscape, these openings were likely larger in extent. Now, I'm going to go through this next section real quick, but this basically lists what are the dominant species, what are the dominant trees, what are the dominant shrubs, what are the dominant, what are called lianas or woody vines, what are the dominant herbaceous species. There may be also some species that are not, and by the way, dominance refers to those that are physically most abundant, and we typically go through different strata or layers. So if we're talking about dominant species within this open grassland, we're going to be looking for those that have the greatest percent cover. You know, maybe 40%. One species might cover 40% of this open grassland. Another species might, cover 20%. But some species may cover a fraction of a percent, right? Those would not be dominants. So what we're concerned with are which ones are the dominant species. And then as far as characteristic, these are often species that are not dominant, but they are important. And we may see them repeated from one glade to the other, or one type of woodland to the next. They're found frequently in different examples of that community, but they're not necessarily the dominants. We also may find, that's characteristic plants, by the way. We also may find lots of species of conservation value. So these are species of conservation concern. These may be endangered plants or threatened species. There's a list of them here. Ideally, we'd like to see animals listed as well, right? If this were a really complete description, we'd have, what are the pollinators and what are some of the mammal species and the birds? What are the key invasive species that are altering these ecosystems? That's important to recognize. Let's talk about real quick community variation and subtypes. So within a given open barren, for example, you may have these different microhabitats or different zones. In this one barren that you see in the upper right, there are patches of open gravel with little grass-like plants that are kind of forming these little islands. Then there's these other areas in the upper right over here, which are like a little miniature prairie. They're all grass dominated. There are some areas that are dominated by islands of trees or shrubs out in the middle of the grassland. They form their own line. And then the edge itself, where the edge of the, it's important to kind of differentiate these, all of these that need to be defined as well. What are the adjacent natural communities? This means what are the what is that type of forest and woodland that comes up next to this grassland? So you oftentimes want to know what is adjacent to the community of interest. And what are some similar communities? Like if you were out there and you wanted to know what could this be confused with, there may be other types of limestone barrens that are different that you want to be able to differentiate. How has this community changed since the first settlers got here, since Native Americans last managed these systems? So we want to talk about, how much has this community collapsed? Have we lost 90%? Have we lost 20%? Is the fire regime the same? Has it changed? Were bison important in these ecosystems or not? Has the flood regime changed? These are all important things to be aware of. If it's a rocky ecosystem like these, have they been affected by quarrying, for example, where maybe a limestone quarry has scalped off some of the bedrock? All these are important to think about. And then the last page here just talks about, what is its present status? How many known examples do we have? How many of those that are known are of high quality? These help to influence things like the global rank and the S rank. Where are representative sites? Are there places that we can preserve as natural areas? And are there places to be managing that we're not? Are there some of these sites all on private property? You know, if 100% of them are on private lands, should we be making an attempt to reach out to some of those landowners to help them become aware of the importance of these ecosystems and work with them to provide them technical advice on how to keep them in good shape? What are the threats? Trash dumping, jeep trails, urban sprawl. The threats are endless. What are management recommendations? What specific type of herbicide is needed? What specific burn regimen is needed? You know, how many times should we hay a meadow or not? All these things are important, and every one of these requires a fairly deep level of knowledge to make sure we're given the right amount of information. What are the future research needs? You know, a lot of the ecosystems and communities of Tennessee have had no one to actually study them. We don't know what the plants are. We don't know what the animal communities are sometimes. We don't know the ecology. There's an amazing amount of missing information still about the very basic landscapes around us at a time when we need this the most. We have abandoned that type of biological research. There's increasingly a focus, and it bothers me, to be honest with you. There's increasingly a focus among academic institutions, everything we do as biologists and ecologists has to be questions based. We have to be seeking the answer to a question. And I just think that's bullshit, to be honest with you. Not everything in science must be hypothesis driven. Not everything in science must be questions based. And not everything in science has to have one of the that I see
Hey,
my
Dwayne,
colleagues making all the time. And they're in. Yeah.
yeah, you're breaking up.
Hey, Laura,
Yeah,
did I lose you? Hey there, did I lose you guys?
yeah. Yes,
For about
back at
60
not
seconds, yeah.
everything in
Yeah.
science.
I got like part of that.
Okay, where did I leave? Where did I leave off? It's very windy
When you're
outside.
saying not everything in science needs to be hypothesis based or question based, not everything in science, and then you fell in a
Yeah.
hole.
Yeah, I went on a rant, so it's probably good that you didn't hear what I said. But I'm going to say it. I'm going to restate it for you. Not everything in science needs to be hypothesis driven. Not everything in science needs to be motivated by a question. Not everything in science must be tested with statistics in order to be science. And unfortunately, there is a growing trend among my colleagues in academia that if you're not doing one of those things, that you're not doing science. And I'm gonna just be frank with you, that's a bunch of bullshit. Okay. There's a very real need to have biodiversity explorers out there. The people that we had 30, 50, 150 years ago, whose job it was simply to go around and study and document biodiversity, is still urgently needed to this day. And unfortunately, that trend is rapidly progressing in the wrong way. When we now, at a time we need them more than ever, we need trained, qualified people who can go out and document life and biodiversity. And I would just urge you guys, as you think about the development of your own careers and you go on to become professionals or finish your master's degrees or go for PhDs, don't fall into that trap. You know, it's fine to practice hypothesis driven science. You're still a scientist, whether you do it or you don't. But do not ever look down on your nose at the people who don't do that. And for a minute, make those people believe that what they're doing is not science. And we have people right here in my own department who very much believe that way and will tell you they believe that way. And it's a bunch of bullshit, to be honest with you. So I wanted to share that with you. I'm deeply passionate about it. We need people who are trained to be able to go out and identify species and read the landscape. And that's as much science as anything. So I'm going to get off my high horse, but I want to make sure I was clear on that point. Last thing is, you know, as with anything, we need to document what's been done previously. It's important to cite who's been there before us and what they've done. It's also critically important to cite our references. As academics, we need to always be aware of that. And then if we know about the community, whatever we can assemble in terms of biological data, you know, list of butterflies, list of plants and trees and birds, this is all important information, especially at a time when our ecosystems are rapidly degrading and vanishing before our very eyes. Any questions about that? And hopefully you guys didn't mind my little rant there. Yeah, Theo, that is the Cumberland Plateau escarpment with the maple leaf oak on it. All right, good deal. Let's proceed. I'm not going to go into this. I just wanted to show you one of the field data sheets that our team uses for documenting a site. And so for the next 3 years, one of the big projects we have to do that SGI is leading is to help describe and characterize the grasslands of the Mid-South. And so we've got some pretty complicated data sheets and spreadsheets here. We're collecting all kinds of information about the structure and the species that make these communities up, and their biotic and abiotic attributes. Here, where we would make long lists of the species that you know, are they part of the shrub layer, the herb layer, the tree layer, and then what percentage of the canopy, you know, what percentage of the site do they make up? So we'll take a lot of data there on these. All right, in the hopefully the last sort of 15 to 20 minutes here, we're going to end up talking about how vegetation is formally classified. And there's basically two kinds of systems that we're going to acknowledge here. One is the NatureServe Ecological Systems classification. In case you don't know, NatureServe is a major nonprofit. Their whole business is centered around data concerning natural species and natural communities. The other classification is called the U.S. National Vegetation Classification, the NVC. And while they are complementary, they really are two different classifications. Let's first just briefly touch on the NatureServe Ecological Systems classification. For this one, this seeks to sort of recognize generally, all natural vegetation types. So it's focused on natural systems, natural forests, natural woodlands, natural grasslands. And it sort of breaks them into those kinds of categories, like I've already introduced, like, you know, wooded wetlands, grasslands, forests, and woodlands. Within, let's say glade types, glades and barrens, then it kind of breaks them into these broad groups like calcareous glades and barrens. That'd be ones that are associated with limestone or dolomite. And then they oftentimes will break those out based on region. So like central interior refers to things that are here in the center of the country or the interior of the country. So you put all that together as central interior highlands, calcareous, glade, and barren. So it tells you a little bit about where it is, what it's like, and what type of ecosystem you're dealing with. And so in this case, this is one ecological system is what we're dealing with. These are called ecological systems. This categorization that I've just told you, this name is the one in yellow surrounded by the red line here. You can see various examples of that over in Kentucky, northern Alabama, and southern Middle Tennessee. These all belong to the same ecological system, the Central Interior Highlands, Calcareous Glade, and Barrens. They all share certain properties, characteristics, and generally many of the same types of dominant species and characteristic species are common to this one system. Next up, though, is the one in green, which is shown in Middle Tennessee. This is the Nashville Basin Glade and Woodland Ecological System. And the reason that this one is differentiated is that this particular glade is a flat type glade that is hydroxeric. It often has pools of water on it, whereas this type is usually sloping, deeper soiled, is not hydroxeric. And this type that's found in Central Tennessee has its own set of endemic species, basically species that only occur in Middle Tennessee and almost nowhere else in the world. And they only occur within these glades. And so that's considered distinct enough to warrant recognizing it as a distinct ecological system, the Nashville Basin Glade and Woodland. The third one is found in a very little tiny area down below Birmingham, Alabama. This is called Ketona Dolomite Glades and Barrens. In contrast to the others, this one is found in a completely different geology, in this case, a very rare type of dolomite bedrock. And this collection, which is only known in one county in Alabama, called Bibb County, Alabama, it has about 8 species that are not found anywhere else on Earth, except these sloping dolomite barrens right above this river called the Little Cahaba River, just southwest of Birmingham. So this is recognized as its own system. And I'm gonna give you one more example, and that is those that are in the Southern Ridge and Valley, part of the Southern Calcareous Valleys and Hills ecoregion of Southern Tennessee, Southeast Tennessee, Northwest Georgia, and Northeastern Alabama. And these are different because they kind of lack many of the other species that those other 3 systems have. And so basically these teams of experts have gotten together over the past several decades and have recognized these ecological systems. Now, each system is intended to embrace a variety of successional pathways. What I mean by that is, like this entire opening that you see here, this entire barren, is intended to capture both the gravel formation that you see in the lower left, the grassland that you see over on the right, as well as the shrub islands and the woodlands. So that entire system with all of its dynamics of grassland to gravel to woodland is part of the same system, right? And so this definition of what it means to be this particular system encompasses all that variation. And that's not true of some of the other classification types, where they would seek to separate the grassland layer specifically, or that gravel patch specifically, or the woodlands. Each of those would sort of become its own separate thing, according to the National Vegetation Classification, which I'll show you in a minute. Here's some examples. I'll encourage you just to kind of read over these in your own time, but these are some examples of other systems. And usually the name of a system kind of brings in 3 components. There's a regional distribution sort of component to the name, so you know where it is. Like cross timbers, oak forest and woodland is referring to cross timbers region of north central Texas and Oklahoma. The physiognomy is that structure, like is it a woodland? Is it a forest? Is it a fen, right? Is it a grassland? And then the environmental setting. Is it in an open plain, or is it in a ravine? Is it up on a mountain slope, or is it in a swale in a bottomland? These all kind of help, these broad sort of sets of characteristics help easily identify communities fairly quickly. Now, by comparison, if you were to look at how many NatureServe ecological systems, which is what we've been talking about, there are, across all of the United States, there are only 872. Of this number, 199 are forest and woodland types. 51 represent types of savannas. 72 are various types of herbaceous communities like prairies and so forth. By comparison, the second classification type, which is the U.S. National Vegetation Classification, is a lot more complicated. And there are almost 6,000 National Vegetation Classification units as compared to ecological systems. So it becomes quite difficult to use in some respects at a large geographic area. There's so many options. The other thing that makes ecological systems kind of easy to use is that they're kind of easy to map. You know, you can use aerial imagery or satellite imagery and kind of pick them out fairly easily if you know what you're doing. It's difficult, like if you look at this aerial image on the right, it'd be easy to kind of call that whole opening, which you can see here on this map on the left. That's the same opening right there, right? Can y'all see that okay? And if you were to search the rest of this image over on the left, you could actually pick out some more of these glades. Here's one right here. There's one right there. Here's one. There's one up here. There's one down here. So you could kind of pick those out and map them. But imagine, and that would be the whole system. Each one of those individual openings is the system. But to try to go in even finer than that, right? To try to say, okay, let me show just the gravel patches, okay, or just the grassland patch. That becomes very difficult to do. And that's sort of the realm of the National Vegetation Classification. So one of the things that makes systems easier to use is the fact that they're easier to involve and incorporate into mapping efforts. And this map I've shown you already is just that. This is a map that shows different types of ecological systems according to the NatureServe Ecological Systems Classification. I'm going to pass by a couple of these things. I've got here little notes for further reading so that, you know, I do encourage you to kind of go through that, but we're gonna go on past that for a little bit in the sake of time. The last thing I want to do just in the last minutes is to touch briefly on this second type of classification scheme. It's called the U.S. National Vegetation Classification. Now, for this, it's a hierarchical system, which means that there's lots of different nested layers. At the very uppermost layer is what's called the formation. And then you've got subclass and you got formation class, formation subclass, formation, division, macro group, alliance, and association. The idea behind this vegetation classification, and this is international. So there are efforts to try to describe vegetation worldwide through the International Vegetation Classification. Here in the United States, we applied at a national level called the US NVC. And the idea is to put together a classification that works for all vegetation at all levels, from the biome all the way from, you know, tropical rainforest down to the very finest level, which would be that gravel patch I just showed you in that one photograph. We want to be able to put names on and categorize that vegetation all the way down. For most of us working in conservation, the group level, which is shown here in the red box, is probably about the highest level that we typically would go. The group is a good, convenient level to use, and it's about the same equivalent as the NatureServe Ecological Systems classification. There are two levels below that, alliance and association, and I'm going to introduce these to you throughout the remainder of the class. So I understand this could be a little bit, you know, unclear, a little bit confusing, but I promise you we're gonna dig in deep on this, and you're gonna have lots of exposure to it. Now you can click on the link on the right, what's called the Hierarchy Explorer, but at this point I probably wouldn't encourage you to do that because the USNVC is fairly complicated and overwhelming. Now, there's several guiding principles to the NVC. I do encourage you to check these out. I'm going to post the updated PowerPoint tonight You've got most of this version already. It's called Community Classification. But this particular version I've edited it quite a bit, so I'm going to post a new version online, but a lot of these slides are still in there. What I want to next do is kind of focus on the finest levels, which are just to show how we might use these out on the landscape. Part of the reason why the US MVC is difficult to apply is that it uses scientific names to kind of name communities. If you're not a botanist with 20 years of experience, it can be quite daunting to try to implement the US MVC. Let me give you a couple of examples. So we go back to the same photograph where you've got the gravel patch and the grassland around it and the woodland and shrub islands. Each one of these has a different name, which would be the association level, which is down at the very bottom. That's the very finest level of that hierarchical classification. So at the association, let's give them a name. The woodland over there in the upper left is called a Quercus muhlenbergii dash Catinus obovata slash Rus aromatica Hypericum frondosum woodland. Now, there are reasons why we use the dash and the slash, and of course, you don't usually say that out loud. And that is that if two species are in the same layer, let's say two trees are both part of the tree layer, we separate those by a dash to indicate they're at the same layer. But if we use a slash, then whatever comes behind that is in a lower level. So Rus aromatica and Hypericum frondosum are both shrubs that are present down underneath those trees in the shrub layer. Let's go to that gravel patch real quick. That's a Sporobolus vaginiflorus dash Carex umbellata dash Heliotropium tenellum herbaceous vegetation. That tells us that all three of those species are in the same layer, and they're all in the, because it's herbaceous vegetation, we're all describing the herbaceous layer, the layer that includes the grasses and the forbs. And then finally, the grassland is Schizocarium scoparium, Sorghastrum nutans, Helianthus occidentalis, herbaceous vegetation. Here you can see we throw one of those species as in parentheses. What that means is it's a characteristic species. It's not dominant, but its presence is really significant. It may not be in 100% of all examples, but it may be frequent enough, and it may be a rare species, or it might be an endemic species that we want to call attention to it. So again, today, the purpose behind this is really just to basically introduce the U.S. National Vegetation Classification. I'm going to tell you something. For the past 15 years, I was I was not a fan of the US MVC. In part because, especially if you're not a botanist, it can be very daunting to read those names and know what the hell you're trying to make sense and be able to make sense with that. As we go forward with this class, I'm going to try to help you to connect to it in ways that are meaningful and helpful. Most of the time, though, we're going to focus on using the NatureServe Ecological Systems classification. It's a lot more user-friendly. Why is it important for me to teach you both? Well, the NatureServe classification is being phased out over the next few years in favor of the National Vegetation Classification. So if you're going to work out in the field, if you're going to work with ecosystems, it really is important to make sure that you kind of understand both of these to have the best understanding. All right, with that, guys, we're going to stop here. I'm going to see if there's anything else. There's a link there to how to use the MVC. The final thing I'll say is this. There are various state level classifications that are really nice. If you're in Missouri, you got a great book called The Terrestrial Natural Communities of Missouri, which is phenomenal. You can go to the Virginia Natural Heritage website. They've got an online classification, which is amazing. There's a link right there. And then in Florida, the Florida Natural Areas Inventory reference sites is also phenomenal. So some states have these, some states have books that are published, and they're great references if you want to know about the natural ecosystems of these particular regions and states. They're an essential for anybody doing work in conservation to be familiar with this kind of work.